Now let's look at the Kapanadze system, however you want to say his name. So here's just one particular diagram. It's not necessarily better than another. This is just one that had no Russian on it, and it had a lot less detail. So I just want to go over a couple of things here. There's been a lot of replications of this, and it really heavily depends upon the ground system. And I want to just say a couple of things about this. So MOT, microwave oven transformer, be very careful. This is a deadly device. It will kill you. So don't be playing around with this stuff, guys, unless you really know what you're doing. So you have basic transformer that you're driving. You can drive it with a pulse width modulator, and or you can use the ZVB, or was it ZVS system, whatever you call it. A driver, you can, so this is not critical what you use here. Again, high voltage output and high frequency. Then you have your spark gap. So notice the coil arrangements here. So this is all wrapped around one tube. In this case, sometimes you have multiple tubes, different coils are wrapped in different places. So it's a good idea to actually wrap them in such a way that you can actually move them. So we have multiple tubes. And I just want to say a few things that I found out in this particular system from others who have replicated is, so notice again, the caduceus coil arrangement here, counterclockwise, 20, 30 in this position, over to 80 to 90 turns clockwise, and then over here, this is kind of a resonant critical coil arrangement right here, 6 turns counterclockwise. So what you have to realize, it's not so many turns, but it's the length of wire, and that's where people go wrong, I believe, in this particular setup. And then of course the positioning of where the coils are positioned in relation to each other. So now notice here, so this becomes like the primary and secondary in one system. But notice also this wire, it goes through the tube. And notice the big, thick, black wire. In all the Kapanadze systems, you always have a big wire going through here. You gotta consider this as a capacitor. You gotta look at the insulation as a capacitance. Both the insulation on the primaries and this as a secondary. So even one wire or a half a turn of wire becomes a secondary. Or you can look at it as the primary if you want to look at it that way. So again, like I said, if the earth is the really the source that you're taking from, and then this would be considered the primary. So what you find in the Kapanadze system, you look carefully at their pictures, notice the easiest way to make a capacitor is what? Answer the question. What is the easiest way? Styrofoam, right? Making styrofoam cups. So you'll notice in Kapanadze system, several pictures will show styrofoam or polystyrene foam between plates or within the tube itself. There's another picture too where one of the wires comes up. I'll see if I can find it here. So Romeo, UK in England, has his own forum, and he brought this out. So this is the one Kapanadze system. So he points out that this is a copper tube, right? And you just tend to think of that as a wire being soldered to the end of the copper tube. But what he said was, no, this tape is covering up the fact that this wire is going through the copper tube. So what does that tell you? It's becoming a capacitor, right? So this is not just a wire. He's enhancing the system by adding a capacitance value to this. You know, you've got an inner wire, an outer wire, and insulation in between. And then he shows a couple other pictures. This is his particular model where he was adding these sheets between either foil or copper discs. And so he showed a couple of these models, not in this picture here, but that had the cheapest form of capacitor. So those are the two significant things about the Kapanadze system. That the wire connects to the ground, and it's a good thick wire going through the center of the tube. So the insulation factor in the wires, the orientation of the wires in the caduceus arrangement, as well as the capacitance of in the inductors themselves, are key elements in this. Creating resonance is just going to enhance how much you get out of it. But with this particular inventor, he's not some great skilled guy that knows all the math, and he can make a system work without having to use even an oscilloscope, I believe, or he can just wind it and just do it. So it's not as hard as people think. There's several key things to do just right, but you can see his videos. I think some of his things are hidden, but again, where is this coming from? This is coming from the Benitez system. So to get the outputs that Kapanadze and Don Smith are getting, they will not tell you everything. Don Smith admits that. He shows you this system. A guy has just replicated it the other day, like 2 weeks ago. I thought it was Don Smith's actual board because he made it look exactly the same, and he demonstrated it. And the only thing I don't know about is the diodes, which ones he was using, if that guy was able to find the exact diodes that Don Smith was using. Now here's the thing I want to say. I've worked with famous inventors who won't be mentioned in this video, but one thing I learned was, in dealing with thousands of people over all my years, I've learned, especially with inventors, that you have to learn to read them. And I'll say this to the credit of one particular inventor who's very difficult to understand. He speaks in his own particular context, and he won't necessarily answer your questions that you ask. So you got to realize people give out what they want to give out. You have to learn to read them. You have to learn to read between the lines. With Don Smith, he had several strokes by the time he gave us the videos that we had 10 years ago, 15, 20 years ago. He already had these several strokes. You can see he's drilling. I didn't work with Don Smith, he's not the one I'm talking about, but he admits that when he's describing this particular system, in the one case he describes this particular capacitor as 10,000 volts. It was right in front of him. So you can't read everything, you can't listen to everything he says as absolutely accurate, because sometimes he's just speaking from memory, and you have to read what's important, or you have to listen to what's important. When he says all of this is not important, you can do this without the with all this. He mentioned several different things you can do without. You can see no coil here at all in one of the systems. He just goes from one transformer to another with a spark gap. What does that remind you of? I wonder if it reminds you of this, because that's exactly what it is. In other words, he knew this. He doesn't give any credit to Benitez. He says he didn't know Tesla did this sort of stuff. He gives credit to Tesla, but he says he didn't get it from Tesla. He obviously worked in a lot of different industry to know some of these things. He talks about having the old TV was a free energy device. He mentions that. Several other devices, he says they are over unity if you understand them and you can utilize them. He obviously talked to people and was influenced somehow to come up with this system, or he could have been very intuitive and just figured out what somebody had already figured out 80 years before him with Benitez system. Either the case is, you have to learn how to read these people is what I'm trying to say. You have to learn how to read Tesla carefully, and when you listen to Don Smith, he talks about what's important, what's not. And he says you could do away with some of these things. For example, this doesn't need to be a center tap transformer. You could just have the one diode here. He comes back to the ground terminal there, and he talks about if you change these values, you could get a higher output. He says this is not needed at all because, in fact, the battery charging, so he's running off of inverter here, right? 140 watt inverter, cheap Radio Shack inverter. He's got a rheostat or a variac, a light dimmer switch that he's cutting the power in half, so he's cutting the voltage down. So he doesn't want to run it at 9,000 volts, he wants to run it around 4,000. If he puts it higher, he said he has to increase all these values to produce more power. So he could, with the 140 watt, without this limitation, step this whole thing up even higher than the 6,000 watts. He said some pretty high number though in his video, but again, some of it sounded like from memory, some of it didn't sound very accurate, some of the components he was talking about. I don't think this particular value of 6,000 volts was necessary. It's probably the kind of things he had on hand, like I use this all the time, not that I have to. You know, obviously it didn't need to be possibly more than 2,000 volts. But when you start finding these parts from your parts bins, you take what you can use and you just throw it on there, and then people will go all goo-goo gaga about a particular value when it may not be critical. So he says don't get too hung over on these particular values here. He did say he had to put this on to make the system in a sweet spot or in resonance. He said that this creates its own resonance on this side, and there is a particular diagram, and some guy's trying to debunk every free energy system out there, or several of these guys, and they make a big deal about this one particular diagram that has this capacitor and the diodes on the other side of this spark gap, and they can't do what it's saying because it's incorrectly drawn. Well, for whatever reason that schematic got out. This one is accurate and works. The other one didn't. But again, when you look at patents and you look at some things, they're for people in the know. They're not for Joe Schmo to just not know anything about electronics and pick up and just do, and then not know what they're doing, because you shouldn't be doing that. If you don't know basic electronics, you shouldn't be playing with this stuff, because and that's why I give you the basic kits. I give you these systems so that you can start playing with it and start getting understanding with it. And they're fail-safe. You can see over Unity very easily. Within a half an hour, this particular system too, you can do this in minutes. You know, I show that, I focused on that to educate people. But to get into the Don Smith system, higher voltage, you're asking for trouble with a danger to yourself. Just from a conventional level, you could really hurt yourself with a high power transformer. Even with low current, milliamps, you could still cause a lot of damage, even from a conventional perspective. But you also do other damage to your body that is not really understandable in conventional terms these days. You can harm your organs and cause a lot of problems internally with your body, as well as destroy your electronics. So this sort of system needs to be encased. If you ever make this system, you need to understand where I'm going with. That will probably be my next video in a couple of months, where I'll show. I did fully encase this, and I actually made it an energy receiver as well, so that, and I did that with the violet ray device too. I'm putting the violet ray device into my special system that you'll laugh when I tell you what it is, but I'm not going to tell you right now. But I was able to get a lot of usable volts out of this system that is normally going off in all directions and affecting you biologically, affecting all the local environment. So this kind of system with its spark gap, it needs to have a type of gray tube, but even not just in the spark gap itself, but across all the inductors. Because we're dealing with a disruptive discharge, it's going to go the more power it creates, the bigger its radiation area. And so don't play with fire. Don't be tempted by the great output of the system. If you're going to do this system and not enclose it, put it far away, that you don't go near it, and make it like a transformer that you see a high voltage system. Keep far away from it, like your high voltage lines and all of its radiation, different type of radiation. But so that is what I want to talk about. Again, notice the coil arrangements going in this direction and that direction. Again, you don't really even need the coil because you have the other system. You can ground this. This is where the ground connection was that he said. He mentioned this several times. There is none of this shown in this diagram here, but right there in the center tap, and I'll show you the picture again. So let's look at a close-up. No. So there's one angle of it. So there's a center tap coming right here. There's the capacitor, the tuning capacitor, and these are the diodes. There's also diodes here. There's the spark gap. There's a neon sign transformer, and this is the step down dimmer rheostat variac type of ordeal here. Cheap Radio Shack. I'm assuming a modified wave, probably not even a pure sine wave, is necessary. Again, don't get all caught up in the details. Like in Gray's system, he's using the transformer, or sorry, the 5,000 watt inverter, but he could have simply stepped it up with another transformer, just like, you know, the Benitez system or this system here. So that's that coil there. There's another angle. Again, this choke, this was meant to charge the battery, but he said in this video that the little battery being in the vicinity will charge itself up. So it's like a 7 amp hour, 12 volt battery. And he did not need to actually use this choke, which was an output to charge the battery back up, as shown in this diagram here. Right here, output to recharge inverter battery. So, and this is what we've found. Batteries can charge up even in the vicinity. And like I said, with my 0 point process, I can do that. So now let's look at maybe a couple other pictures. That was just something different. So again, this one right here, this picture is, notice what's missing from this picture. You've got your inverter, so you got your input here, inverter going again to your high voltage. You're going out to a bridge rectifier. He said these are just a 4-way bridge. You've got 2 diodes in here, or 4, it must be 4 diodes. Then coming out through I see 1 wire here and 1 wire there coming down through here. Anyway, these are some pretty serious caps, 3 terminal caps, and there's no coil. There is no coil here. Now this was a special transformer as well, so he was going to get higher gains out of this transformer, but you still can use a regular transformer. That's important to understand. Like, it seems that almost every one of Don Smith's systems use something. Like he said, he kept insisting that these particular diodes, you can't get them unless you get them from me. Looks like these are exactly the same. But I think he was meaning you have to order a lot of parts in order to get these. Since his day, these parts have been available. And so, I don't think there's anything quite exotic in this particular model. But when you see one of these tubes in his one video where it's wrapped with piezo material, whatever you call it, then you can see that this was another gain, another system where it's a gain. And if he uses that in the same transformer, he's going to get a higher output. But he downplayed those things. Like, in other words, while they may give you a couple of times over output, you still can get a reasonable output from the other, the normal way of doing it. This particular model, he talks about, this is basically like the MEG system, system, and but he actually, by accident, he just used 1 wire around here. Instead of using 1 wire, he used 2, and then he pointed the extra wire up as an antenna, and he got many times more the output. So again, you have your neon sign transformer here. He's just pumping it up, and then I think that's the bridge rectifier, and that's it. Very basic system. So again, this is all Benitez system with adding a few modifications here and there. So here's some different schematics that people have stumbled over, trying to figure out which each part is patent. You know, there's another angle of that same system where you can see is just clearly 1 diode here and 1 diode there, so a half bridge. coming through there. Danger, high voltage. This one is an interesting arrangement. Here's another Don Smith rotating magna electric. I can't even read now, I'm so tired. It's a metal wheel, but notice again that the coil arrangements, the capacitors, the transformer, the 7 amp hour battery again. Here again is another description or diagram of, here's something interesting to read. So you got the coil coming in here, coming back around the same direction, going out to a load. Low power sine wave oscillator, and you're creating this and you're getting a gain. Notice the battery configuration, or the magnet configurations, north, south, and then the south pole right there. And this system input power is almost completely reactive at resonance, with output in the load being real and in phase, of course. Variation of the magnet positions will result in an increase in the output without any change in the input. So this is what we see in all these types of systems. You get a sweet spot, you get to a point where you can load down, like I show my motor systems, where we load down the generator coils to a certain extent and the motor speeds up. And we short out the coils, the motor speeds up. If we remove the motor, short out the generator coils, I meant to say. So we show in, if we remove the generator coils, the whole motor will be slower than shorted out generator coil. Now this, some people tried to say, well, because the generator coil is there, it's acting as the load, slowing down your motor. But if we have a faster RPM, less amp draw, without the generator coils in there and shorted, then my point is made. That's the way I made my motor, to demonstrate that aspect of things, to show you that just like Tesla's picture, where he was running out the this particular picture here, and the like of his pictures like this, where he's got the load shorted with a copper bar, he's still running these loads, you know. So the point is, it doesn't make sense. Only in disruptive discharges, high frequency, high voltage, unidirectional systems can you notice that. That kind of gain. So shorting out coils, sometimes things are opposite to the way you think of. If you just think in terms of resistance and amperage, you're never going to get anywhere. You're limited by this little black box that you're stuck in, you can't see out of, because you need a clear box. And you need to think about the magnetic component of the electricity or the energy, and it behaves in a different way. It's another part which what Don Smith talks about is the energy spin. He uses his own terminology, and he says it spins this way and produces one aspect of the energy, and it spins the other way and creates the other, and then he brings them back together to have the full power. So separating these is a learning experience, the difference between all the different types of energies and processes. And so this particular system will give you a good idea of the different types of energies. But I want to recommend to go to the beginning. Start with, consider everything about Cook's patent and read his article, which I'll put the link up on my page. Also, go to Benitez and read through these patents. Line by line, I've brought up all the major important points, but get a working feel of it. Build this. This is the easiest one to build. It can be done very quickly. You can make your own induction coil just with a transformer and an interrupter. You could use a buzzer. You know, you could use a bunch of different things to create the oscillation. You know, we use transformers nowadays, and to create, but we sometimes, in doing that, have our much greater losses, and we don't have always the best way of creating these higher gains if we don't know what we're doing. So look into all that stuff. I think I've covered everything I want to cover here. There's so much more. I usually take 2 days to do this, this presentation, so I can't do everything. But I covered over most of the ground, pretty much. One thing I could just draw attention to, I'll put this link up to Tesla coil safety information. There's 14 sheets of detailed information here. Some of it is just an outline though, of very serious dangers of Tesla coils. And then that would relate to all these types of systems that are the higher voltage, higher frequency, higher amperage systems. Again, watch out for ozone. Don't breathe it in. Many people don't realize the danger there. All sorts of other dangers here. So look at this link, and I don't want to hear your wives. I've had 2 different wives tell me about their husbands experimenting and how things have been very bad for them because of a Tesla coil, even under 1 watt of power. So save your family, save yourself, and don't hurt yourself, don't expose yourself. So you can see again where these were all at, 24.4, 1171. Start it all up again, and just keep on going. Watch the cap, pulse, hear the sound difference. Fun little system. Now again, oh, I gotta bring the camera around. I'll show this while it's running so that you don't think there's any kind of monkey business. My phone is just, or this is just about to stop recording anyway. So you can see again my transformer that I'm using here. That's the bigger gauge wire on it, and this is, I guess you can consider that the secondary side. And how I'm just running. Okay, my camera just did stop, so let's go back again here. I just stopped it for 1 second, so let's look at the brightness of these lights. We're not talking about a lot of power, but it is excess. So there's the oscilloscope. You can see the divisions. And then let's look at this more closely. You can see when I stop it. So this is stopped, and then I have to Just kind of bounce it back. And see, this thing goes up and down. That's why it will change different power. You can hear that's a little bit higher power level. And we'll look at the meter more closely here now. See, now it's a little bit higher, so I can adjust this. See, it's 86. I was doing it. It'll drop down. Different power levels, depending on how I change it. Kind of will settle there. I had it down to about 50. So again, if I put this in a different spot. Oh, what is different, what is interesting about this is if I do connect up here, we can see 60. But let's go over here between the two negatives. 42. And let's go over here. 29. You know, this is the other side of... So we have different amperages. Now, of course, this is not your best meter to use, but you can see that in a lot of these systems. Even in my system, where we're running the motors, you can actually place the meter here and here, and there's going to be a difference at this Y terminal between what goes into the motor and what goes here. There's going to be a difference of amperage right there. And that's kind of splitting the positive as well when you consider that in a double sense of the term, because we're splitting the positive between here and there, and we have a floating ground system here. So yeah, this is the whole thing running. I'll show you this tube goes in and out. Maybe we'll see this kind of changes when I... So we'll look at this as I push the tube in. I can get both angles. So you can see pushing that in and out will change also the voltage charging rate. As I pull it out, 94. Yeah, it's just a little bit different. And then, of course, like I said, running this, let's look at what we were doing by taking off to the capacitor right here. Actually, it's going up in this case. It's changing. Now I'm going to put it back on. So again, we can see the oscilloscope going crazy over there with the spikes. So there's it on, there's it off. See, it goes down to 0.1. So there it's still off, and now it's on. So you can see a gain sometimes. Definitely not as good to leave it off. Now you can run this, like I said, across. See, now it's already stopped. So you can run it across here, like normal. so you can hear the difference. See, this is still registering. It eventually will ruin these meters. These digital meters get ruined with this high voltage, high pulsing. And so let's look at this underneath here so you can get a close-up view of what I'm talking about. So I had disconnected that. It had been originally connected through right here. And this wire is broken, so you can see the kind of rust on the wiring, and so I just connected up to those two wires coming out of. You can see they come out from where the coil goes in. Nothing special there, but you got to kind of map all this all out to figure it out. Well, now it wants to start up again. Now the thing about it is you got to be careful if it does put a dead short across it, that you recognize that, so that you don't just run directly through both primaries here and not create the pulsing. So there it is at rest again. And so yeah, it maintains the batteries while it gives you a load. Now I was running bigger loads on this too, with these 100-watt modules here. Now I put a bridge rectifier across these because they will be damaged. So we can run this. See, that creates the light that I need. Good charging. So there is a sweet spot. There's a sweet spot in all this. Now I'm using the secondary winding on there. I can also close the switch and run that from the primary winding here. But that's another whole story. Anyway, you can play around with this a lot and do some fun things. And it will just show you, again, what we're doing in our motors, except you don't get any free mechanical power out of this as you do the motors. So that's why I generally don't go this route, because I like to get, additional source of energy through the batteries. Welcome to Renaissance Charge Videos. This is video number 4, I believe, and this was done after the next part of this video, but I decided to show a bit more here in the meantime. Still working on editing the last part of the video, and there may be a 5th video as well. Actually, there may be a lot more. So what we have here again is going back to the one Benitez setup, in which the first patent, I think the 3rd section, and so we're running 24 volts into 12 volts here, and we have the induction coil here with its output secondary winding. Now there's 2 windings of wire inside this particular coil here. This one right here is an example of an AC one that is from a violet ray device, only has 1 winding. It's not what I really want in these experiments. I'd like to have the secondary winding completely isolated. So in this case, I'm actually running off the opposite, the way I normally would think about running it. Well, first of all, I would rather have my secondary winding completely isolated from the primary winding, and it's not that way. It is connected in this one wire, as I showed in an earlier video. it's so wrapped around itself that I'm not going to try and separate them and ruin this coil. So I'm leaving it for now connected. It does, it is set up this way anyway in the one patent that I've shown the diagram for. And try not to say too much this time. Well, so I say well or so, and something else like that. So we're running off of the secondary. So the secondary is actually creating the input instead of the primary. Just doing that to bring down the amps and run it actually backwards. Not that I should be doing that, but it still works. So that's the way I have it set up here. This little red wire here is the smaller gauge wire, the secondary wire, and the primary is usually run that way with the switch closing. So what I have here, which was very odd what just happened there, it must have been because the capacitor is across this that it just made that little bit of action there. So I have two oscilloscopes across either points, two probes of the oscilloscope across either side of the induction coil, so you can see the difference in the waveform. And what we want to look at is the relationship of this capacitor. Now, I want to talk about two different things here in this video. One is this setup the way we have it here. And then maybe I'll go into the final patent that we talked about at the last video. Or actually we're going to get into in the later part of this video. So I may include that section after the video that I've already done. I'm not sure yet how I'll edit it. But I want to talk about here the difference between the capacitor across the contacts, the points and condenser in your old gasoline automobile when you had points and condensers when I was a kid. Well, normally that's across the contacts. But in the Benitez patent I showed how we put it across, because we're running something unique here, 24 volts to 12 volts, 24 volts to 12 volts here, I put it across the negative according to the enhancement in the patent. So you'll be able to see the different waveform here when we do that. And what's interesting is you'll see how the voltages change, and they kind of take a second to adjust, and they go up and then they come back down. So that's interesting how it regulates to the load. So what we're doing here with this going across, not the terminals. Remember, we said, Benitez said that you don't have to go across the contacts to use the secondary application of this cap. Now, this is a really big cap. It's a 2,000 volt, 1,000 microfarad capacitor, and it is actually polarized apparently, and I didn't realize that, but I'm still going to use it. I've used other capacitors, and in this particular case, it seems that a bigger capacitor works better. Not much difference than this 10 microfarad, but it seemed to make a difference between the 0.015 microfarad, or I've got a couple of these high voltage small caps there. And so on this particular place, I don't want people to get confused. I'm going to run the capacitor in this place in which Benitez patent makes a big deal about. He says as many times as you can charge and discharge this capacitor, you will increase the voltage and power of this particular input battery, and therefore charge up these batteries more readily. Now the other thing is, I do have another cap here that I will put across the points, and you'll see the waveform differently there. Now in that particular case, that is a different thing than the final patent, which we'll talk about at the second part of this video. What we want to do is essentially do the same kind of thing here, but reduce the amount of batteries. Go to two 12-volt batteries. The negatives are still connected together, and what we're doing is one battery is powering either an inverter with a variac, or actually an inverter going into a transformer, stepping up the voltage, not too high, but you can go really as high as you want. But in his patent, he wasn't going too high because of the limits of the diodes that he was using, or 600 volts or something like that. So, and I think the higher voltage is more biologically dangerous too, and I do have a solution to that I will be bringing out in the near future. I'm working on that day and night. Well, in this particular last patent, where we have the two batteries, and what we're doing is we're running the, either we can run a DC motor that ran an alternator, as it said in the patent, or we can run directly into induction coil, or nowadays we can run like the Don Smith system, the inverter with a variac. We can control what voltage we want. We can add capacitance and the spark gap, which I have a number of spark gaps here somewhere. Again, the violet ray device is a big spark gap here, and so so you run that. This is where the Don Smith, the Ed Gray system, and all these are the same, where we're creating off of a 12 volt or whatever voltage battery, relatively small, relatively low voltage DC source, which then can be recharged. In this case, we don't want to run the recharging at the same time as the input. This is not really good for a battery to do. So interestingly, Benitez never did that, and Gray never did that. So what he did then was went from the 12 volts in my my diagram, which I put on the front of the last video. You have 12 volts going into the induction coil as a replacement to the alternator, which that's the first way he ran it, and it seemed to maybe be a better advantage. Maybe not, because you have your losses in that, but you can tune it to go into resonance, which then could probably add to the whole process, you know. But I am the type of person that I'm trying to get away from making things too difficult, or having things fall in and out of sweet spots and all that. I like to keep it fairly simple for everybody to do. So going into an induction coil is great. We have a spark gap in that, as he talked about. but we also want to go directly then into an actual spark gap, and this is where if you have just a straight transformer, you're going to need that. If you have a battery going into an inverter into like a neon sign transformer, which I'll show soon, and then you've got from there going into the spark gap. If you're paying attention to Benitez system, like I'm showing in the next part of this video, you'll see how it goes into, after the spark gap, it goes into a coil, or sorry, a capacitor, condenser at the time. And then it goes into a bridge rectifier, and then back. Well, actually, there is a rheostat. And it's probably not just your regular rheostat like this. It's probably more of a real inductor type of like that cage coil, they call it. The name escapes me right now. But anyway, in which there is some inductance involved, because he makes reference to that in the patent. That you've got to really pay attention to the inductance, the capacitance, and the well, the voltage, of course, but there was one other factor, it escapes me now. I guess the impedance of things, so forth. So anyway, what we want to look at, or what you have to consider in, for example, the Don Smith system, where he has the, after he's got the, he goes from a battery to inverter to the neon sign transformer, which is a big, it's a small transformer that boosts it up to maybe 2,000, 3,000 volts. And then from there he goes to a spark gap, and then a coil, and then a caduceus coil arrangement. And a lot of people are kind of stumped at that point. They don't really get it into resonance, and they really fail to see what Benitez was showing. And actually, if you look at Don Smith's system, you'll see another example where he runs the neon, or actually the inverter, I guess, into the neon sign transformer, or actually directly into a high voltage transformer. From there, he just goes through some diodes directly to the to a big cap bank. Now, there is two wires on the one board that seem to be beside each other, so I'm assuming there would be a gap, spark gap in between that at that point, or some other factors, but there's no coil needed. If you listen to this video where he's in this office about 20 years ago, I think it was, and he's interviewed for about 45 minutes or so, and in there he says all these things are not necessary. In other words, the coils and various apparatus. He said people were looking for that, so he put it in there, and that's what they're expecting, or something along those lines. So there's various ways to do this, and Benitez system is a simple way. Now, where Benitez system focuses in, and I'll get into that in the next part of the video, is the spark gap. The way the spark gap is magnetically quenched, and I think there's a big part of it where you're picking up the output from the spark at this angle here, which is where the magnetic fields are produced. I think they're picking up, they're also collectors in the system, just like Ed Gray's tube is at right angle to the spark. And we'll get into that later on. I'll do some demonstrations of that. There's a couple of them on the internet, some really old videos to look at. And there doesn't seem to be much activity in the last couple of years being posted. So that's surprising to me that somebody hasn't run with this for as many years as it's been known, or at least publicly run with it. So again, let's go back to this. Let's look at the capacitor values. Now, with that one capacitor in the last model I was talking about with the two batteries, the last Benitez patent. So two batteries, one battery powering the induction coil, going to a spark gap, then going to a capacitor, and then to a bridge rectifier, then to the charging battery. And you run your loads off the input battery, actually, according to that patent. So in that case, we want actually a small capacitor, and of course rated to the voltage, usually double the voltage that you're operating under. But he talks about 0.2 microfarads. So we don't want the big capacitor there, because what we want is as fast charging of that capacitor as possible. And the thing is about that is, well, we want a little bit of airflow to blow out the spark gap, and that cuts it off more rapidly so that there's more rapid frequency. So then what happens is we also have the magnetic quenching to also shorten that, and that gives a much greater efficiency, and you're not wasting so much energy in creating a spark. Actually, we're suppressing the spark. So what Benitez talks about in the patent is that we want as fast, as high a frequency as we can get there, and therefore we're charging up and discharging that cap as much as possible. And rather than pushing current, pushing farads, microfarads into the battery, we're hitting that battery with very small pulses, up to 1 million times a second, which is extremely fast. And with you can only get that kind of speed with the right kind of system. Like this is very limited here with this hammer, based upon the flexibility of the bendable element there. So if we get into other electrolytic type of interrupters, as we talked about, then we can go faster, as he says. Right here I'm just showing the bare bones basic, and I'll do a demonstration of that a little bit later on, of that particular system. But I want to make mention the difference between this end of the circuit with its capacitor would be different than on the second system, where we have the spark gap in that particular system. So What else did I want to say? I've been trying to convey the idea of where the energy takes place, where the increase takes place. And there's a lot of talk about it's in the special caduceus type coil, it's in this place or that place. But I think it's in several different things that we're doing here. And in the first case, when we have an induction coil, we have a make and break. So as soon as when you make the contact, you obviously have the closing of a loop through the primary, in which it draws energy, and that's the closed loop. And at that point, it obviously energizes the iron, the soft iron, and it opens up the circuit. And at that point, we'll see that it turns off. Right? Obviously, it's open. There's no current flowing through from the input. And of course, if we run the capacitor on this side of the circuit, so I have it here after the circuit, then what we have here is a real open loop here. We're not across the contacts. And I mean, it is an open loop anyway with the capacitor, but not even with the capacitor there. We have a real open loop. And at that point, we go into an oscillation, which we can see on both coils here on the oscilloscope. So that would be, let me just show that while we're talking, I guess. Now you saw how when I first connected this up, there was a dead short, right? Because I have to kind of kickstart it to get it vibrating in that way. Because this is an old model, it's not working very well. So now what you can see is the waveform while we connect up. See, there's disconnecting that cap. So if we connect it again across where it's usually connected, which would be right here. Of course, this is a really big cap, so we don't really want to do that. It's really too big. Now we can go. Now, unfortunately, this kind of is really sensitive, so this would be across the terminals. Now I just saw it kind of light up more. Of course, it was drawing more power when we did that, so-called, because actually we've got the capacitor right here. Anyways, I wanted to show the difference. That's across. That is across the coil. See the waveform change there and just kind of dampen it all out. So there's it open again. So you can see the lights too as well, not too much of a change, but you can look at the voltages change under the various ways. Now, what we can do is connect it in several places. So we can disconnect this. I'm going to try and keep this connected somehow. Can't let that go for too long, the voltage will change. So let's let that voltage come down a little bit because it was just crossed. So now if we connect up again, this thing keeps timing out on me. And the position of the ammeter will change everything somewhat. So let's connect this across so now we have it directly now that's interesting. So you can see there, that's right across the one set, the primary coil actually. See how that boosts it way up there, of course, probably drawing a lot more. So there's a number of places where we can see enhancements. Now we're at 100 volts for on the input side. Well, I guess we call that the output side on the stud side. And only, actually, sorry, that's the other way around. We're only at 5 volt intervals on the one, on this number 1 channel, the yellow channel, and the blue is across the stud. So that would be, I guess you can call that the output. And those are 100 volt divisions there. So we've got 1, 2, 3, 350 or so volt differences there, or spikes up and down. So you can see that. You can look at, that's across the and then, like I said, we can run both of these. Oops. This is not meant to give you that much precision, it's just to go over a couple of things. So now if I put this cap on, look at the difference. I already have this one connected. So there's a lot of different relationships here with what we can do. Of course, I also have this slider that isolates the, I think it's just the core. Yeah, it's just isolating the core material from the windings. So that will change the relationship. I'm just going to leave it. I don't want to change everything. So we're talking about running some decent loads here, because we're talking about milliamps here. 50 milliamps, 12 volts difference in potential, pretty much exactly. And so the battery's charging up at the rate this one's discharging. We've got 4 batteries all together, swapping around. So this is like my motor situation, except we don't have the extra torque. We have running of this particular load, and which is analogous to it. So this could be made at any size, but I think really we can avoid the 4 battery bank system like this. This is a simple way of doing it. It's a lot easier this way, but I think we can reduce the number of batteries and go with the final patent, in which we're running 2 batteries, doing the same sort of thing, but now we're using a spark gap. And of course, this particular system too, we can run across here. We can run the extra transformer. So now we change. It's got almost 90 milliamps here. It's going to change a little bit. Anyway, what I'm saying is, so we can actually open this up a little bit more. And you can look at the waveform there. So again, so the difference, that's disconnected, that's connected. We got certainly a lot more power when we add this cap in there. Just like Benitez said, there's a significant increase in power. And like I said, we can also do see the difference, just dampens it right down. When I put it across there. Now again, we can take this one off. Now it's just across, well actually that's not even across the contact. Now it's just flat line. So where does the excess take place? Where does the gain take place here? Like I said, you have the make and break contact. So you have energy coming from this battery bank until it opens up. Then you have a ring, and that continues to produce action in the coil. On both coils there's a ring, as you can see right here. See, when it stops, it stops. So there's a ringing for a while. That's pretty good. It actually gets larger there for a bit. And of course then it will turn on again. Not for a while. It's a pretty big off time there. So that's where your gain is. That you keep charging up this cap several times and it produces more output that way. So this is a simple way of describing it all. I can't get into all the complexities of it, I'm not qualified. But what I'm trying to say is you have to have an open loop, of course, is what I've always said. So you have your off time, and then when you offset the physical world, let's say, then it wants to balance itself out. So it wants to reach equilibrium. So then it comes back. It's like elastic band. You know, and this is where we see it in the wave, and there is more gain. So that's the only way you can explain it. There's nothing else happening here that really can explain this whole thing. And so really all these different inventions are just a way of exploiting these basic principles of an open loop system, a imbalance in the environment, and what the energy is, where it's coming from. These are all things that some people think they know the answers to, and I think it's probably a lot more complicated. And centuries from now, we'll realize how little we knew right now. But we can do this. The thing about this is we want to make this safe, and we don't want to run these kinds of systems at higher voltages. Like this is only a couple 100 volts here, so we're not really producing anything, any kind of serious radiation or anything, but it still is producing a radiation, and we want to be careful to enclose it. Now I have a couple of things that I'm going to do to enclose these systems before I start selling them, and offer that as very important, that nobody else has offered yet. So I think it's very important for our safety that we do that. So there's what we have right now, and anything else I will add to this video in text form or whatever. And hope you enjoyed it. Thank you.